Hello, this is your host, Mr. Marson, and today we are going to be solving multi-step inequalities. This is not much different like you've done in the past when you solved equations, and you're still going to have to use inverse operations to isolate the variable and get it by itself. The only difference is what the answer means. So if you have the equation x plus 2 equals 4 versus the inequality x plus 2 is greater than 4, you would solve it the same way by subtracting 2 from both sides. They cancel out, so here x equals 2. Over here do the same thing, minus 2, they cancel out, so x is greater than 2. That's a 2, it's kind of sloppy. So these are really the same thing, but the difference comes in how you interpret the answer. On the left in this equation, x equals 2, so x is only one thing, it has one correct answer. On the right, x could be numerous things. It could be a set of correct answers. So anything bigger than 2 would end up making this true. And on the right, you could take it and plot it on the number line. So if you want to plot the answer, x is greater than 2 on the number line, we would just go to the 2 and circle it. And because it's bigger, all these things would make it true. So if you plug 3 or 4 or 5 or 6 into this equation, it's going to make it bigger than that 4. This isn't much different than what we've done in the past, but they will get slightly more complicated because now you can see they're multi-step. So this is just like we've done in the past with I told you the analogy of taking your shoes and socks on and off at the beginning and end of the day. It's the same thing. You still want to do the things away from the variable first to isolate it. So in this example, the first thing that we would do be to subtract 2 from both sides. So then you have negative 12 is less than 3x. Now we have to get this x by itself still, so the inverse operation of 3 times x would be divide, and you end up with negative 4 less than x. And if you want to, you could flip around, so x is greater than negative 4. These really mean the same thing. Then we could take this and graph it on the number line once again. So if you come to the number line, you would just circle the negative 4 because it's hollow, and x is greater than negative 4, so the arrow point here. So all of these things would end up making the equation, or inequality rather, true. Another example would be negative 2x plus 4 is less than or equal to 3. The only difference this line makes is now it could actually equal 3. So when we go back to the graph, the dot would have to be filled in, the circle would be filled in. We go about this the same way by taking the 4, because that's the furthest thing away from x, and doing the inverse of it, minus 4, then 3 minus 4 would be negative 1. That cancels out, bring down negative 2x is less than or equal to 1. Now we take both sides and divide by negative 2, divide by negative 2. They cancel out, so x would be less than or equal to a half. And since these are negative, that would be negative over negative would really just be a positive. So it's positive a half. And right now you should be yelling at your computer screen because I made a mistake. Do you realize what the mistake is? I hope you do. If you remember from before, whenever you move a negative by multiplying and dividing, the sign gets flipped. Remember, you must flip it. So this answer is actually wrong. It's x is greater than a half. It's kind of sloppy, so let me rewrite it. X is greater than or equal to 1/2. If we graph that on the number line, it would look something like this. The half is about there, and it has to be filled in. X is greater than it, so it would have to go that way. So that would end up being the solution. If you could please try these problems on your own and put the answers in the Google form to the right. Good luck.